Okay, welcome everyone to Robot Builders Night Virtual for Tuesday, February 11th. We'll have the usual agenda today. We'll have some DPRG announcements, and then we have a queue going, and then we'll go to open mic. So DPRG announcements. The vote on the bylaws change passed. So thank you very much to all the members who voted. So we now officially in our bylaws have removed the librarian position from as a board member and have instituted an IT officer as a board member. And I sent out a email. If you haven't seen it, please let me know. I'll resend it here probably this weekend. But we're now having a vote for an election for the IT officer because it's an elected board position. Eric Cheney graciously volunteered to be our first IT officer, and the board was very grateful for his offer, and so he's the only nominee for the position. So please vote from using the link in the email. The other thing that while we're having a vote for IT officer, at the January meeting, Mark Reynolds graciously offered to step up to be VP for the next year. So thank you, Mark. And but to we had already elected Carl as VP. So Carl graciously offered to step down as VP to make a spot for Mark, and so Carl is going to be off the hook. He tendered his resignation the other day to the board, and I just want to say thank you very much to Carl for his support over the last year. He's been a wonderful VP to me in so many ways, in supporting, in giving helpful advice and guiding discussion, and just a wonderful person to have as a VP. And so I'm very grateful for your contributions, and thank you, Carl. And very excited to have new blood on the board, new face, new ideas from Mark as the hopefully incoming VP, because that's the other position that's being voted on in the election that's going on currently. The election will be finalized at the February meeting. And hopefully we will make quorum, and everyone and Mark and Eric will be voted in onto the board, and we'll have two fresh faces on the board bringing new ideas. I think that's a healthy thing for the club. There's absolutely no disharmony involved in any of this. The librarian to IT officer was just, let's make this board make sense in light of the way the club works today, as opposed to how it used to work 40 years ago. The other is, hey, fresh faces on the board is good, and Carl is a soldier without equal, having endured 4 years as president and then a year as vice president. The man deserves a break. And I'm very, very happy that Mark was willing to step up to that. So thank you. The announcement is the Kicad. Doug is going to give a talk on how to use Kicad at the next at the February meeting. So I'm very excited about that. That's I've been wanting to learn how to use Kicad for a long time. So excited about that. Did I miss anything DPRG related in that list that anyone knows of? Okay. If not, we will go to the queue, and Scott has an impressive looking lineup of what do you call, I've spaced the name.
Yeah, well, they're quote unquote robots. But first of all, I want to say, Carl, you're going to always be known as a quitter. But no, in all honesty, excellent job through some difficult times and a lot of transitions while you were at the helm. I think you did an excellent job and left a good platform for Paul to pick up on. So just there to Carl, I just want to express my gratitude for everything you've done for the club over the last several years.
Well, thank you. Thank you.
Even though I'm still going to label you as a quitter.
Well, that's we'll have an answer for you, Scott, on that one. But let's remember that Paul really picked it. He jumped right in, and this is Paul's second round as president of the club, right? And if I've heard rumors, he's done amazing things in the first round, and I think we've all seen firsthand that he's done amazing things in the first year, last year here. So I think we should give a round of applause to Paul, really. So
thank you, Carl.
Having said that, let's stop talking about me. I want to hear about Scott's robots. Well, I don't really, but I'd rather hear about Scott's robots.
Okay. All right. Yeah. Enough about you, you quitter. So basically, I kind of proposed or trying to generate some interest in a sumo contest in the spring competition. So I just thought I'd show some of my sumo robots, kind of identify some things I've learned through different competitions, and just kind of show I have a new one that I've been building on that I was also going to show. So anyway, to start out, this one is actually a kit that I'd won, and it has no brains to it. It basically just has a couple of sensors in the front, and those drive right into the motor drive. So this is kind of an example of how simple a sumo robot can be. It has, line detectors, which is a requirement for sumo because you don't want to run yourself out of the ring, right? So you need to be able to back up and so you don't lose, right? So this is like I said, just an example of a really simple kit, how simple sumos can be. Just a couple of sensors and the line follower. And actually the line sensors just are ordered together and both motors go in reverse if any one of them goes off. So again, and this was a kit, I don't know if it's still available. Just uses some voltage compare really is all this is. And you got the pots that adjust it. So that's kind of a simple one. This is a robot that I competed quite a bit. It's fairly successful. It was a kit as well that I modified quite a bit. It runs really off of, you can't really see it, but just modified servos where the servos just rotate continuously. And so it's not really that powerful. Again, you got two sensors up front. You got line sensors underneath. This one's just got the two on the ends. It's got a little microcontroller, a little microchip processor on it. So again, it's not that sophisticated. This is again a kit that I modified. You can kind of see the original CPU board here. So this is another one that I had competed quite a bit. This is kind of the third generation of what I learned from these other robots, and kind of tried to integrate it. Same kind of thing, two sensors up front. This one had the enhancement of like a short range sensor, which was very effective in competition because when you get, this one goes off at like 1.5 inches or 2 inches or something. So when I saw something directly in front of me, I just turned the motors on full speed and basically slammed into them. And in competitions, it was really effective approach because you break their traction and you just slide them right off the course. And this one also introduced a rear sensor so that, because really with just the two sensors in front, you don't have a lot of field of vision. So, you know, a robot could run right past you or be behind you and you wouldn't know it. So this one, again, has a rear sensor, and the action there is if it goes off, I spin around until I get a sensor reading in the front. So I took kind of all of that, and this is the one I've been working on, and it's actually a tracked kit from Polyloo. They sell these kits with the tracks and the wheels and the motors, and it's like a plastic chassis. So I ended up making an aluminum chassis frame. Again, I got sensors here for lines. Again, and this one actually has sensors in the back, so you don't back off. That was another. I've lost a couple of those contests by backing off the course because my line sensors were in the front. So it's helpful to have sensors in the back too. Again, this one has a sensor in the back, and I just have kind of put this chassis together. So it doesn't do anything at the moment. I haven't written any software, but I kind of like the dozer look of it. So I'm calling it D9 for a D9 dozer kind of look. I don't know how sophisticated the software will get. There's not a lot I can do with this micro. But another thing I kind of learned, and you notice on this one, it's got a binary select switch. And what I did there is I had different behaviors for different competitors. Like some competitors would want to, basically would just want you to come in to them, and they would try to high center you. They would try to scoop you up from the bottom. So I had an activity for that. There's other activity or behaviors where at the beginning of a match, they would just run right at you. So I had like an avoidance behavior. So depending on the robot I was in competition with, I can select kind of a behavior or a defense almost in some aspects. Also had different search mechanisms where when you don't know where your opponent is, how do you search for them? So, like I said, there's just kind of some examples, some lessons I've learned about, you know, having back sensors, things like that. So I just kind of wanted to show a little bit, maybe drum up some interest. I don't know, Paul, have we officially said we're going to have a contest? Or are we still waiting to see if we're going to have any competitors? I got a couple of matches I could come up with right here. So, but that's not a very fun contest for just one person. So,
I think we said that last meeting I heard that this discussed. I think we said if there are two competitors, we'll have a match. Meaning two people.
Yeah.
Not one person with two robots. But one thing that I don't know if I ever heard a resolution to, or maybe there was one, was what scale or what rules are we going with? Mini-sumo?
Yeah, these are all mini-sumos, which is basically 100 millimeters square and 500 grams. That's the restriction you have. Of course, there's other rules with the sumo. You can't have offensive weapons, you know, certain things like that, that dictate. And, you know, you have a delay at the beginning of the contest. And that's kind of like to simulate them bowing, you know, the competitors recognize and honor each other in a real sumo match. So it's those kind of rules. And I don't know if they're on the website. I know we have a set of rules. I would imagine they're still posted on the website if anybody's interested in the details. I think we had some work we needed to do on the course, you know, if we get a couple of competitors together. So
yeah, I wanted to share something, since, you know, Scott went to all this, and this is not near sophisticated as Scott's, but this one here is, if you pin me, this was an idea for one of these, like the beginner robot. Let's see, beginner robot based off of that. So you can see that it's been turned around. So now you're looking what the back is now the front, and there's a little Harbor Freight roller that's on. So now it's going to be tilted down. So this is going to be just above the ground, and it had 2 sensors in the front, 1 sensor in the back. It had a plate in the back to give some protection, and these shields were so that if it were to try to keep things, otherwise if somebody ran up on this, you wanted it to go up. You didn't want it to, run over. Now this, like I say, this was just a very low thought practice idea based on the build your own robot, separate little robot. Now the problem, Scott, is you can definitely see this is bigger than 6 inches, and probably weighs more too.
Yeah.
I don't know. 500 grams. That's a pound. What is that? A pound? 1.1 pound? Something like that.
Yeah.
I believe. Okay, and it might fit that, but so I'm just saying is, if we could loosen up the scale size a little bit for beginners, it might get some more interest. I understand why they do mini-sumo, but that's not that's not necessarily a beginner class unless somebody is going to buy a kit. If they're trying to build their own, it's going to be a little bigger.
That was part of what I was driving at, like the.
Go ahead. I'm sorry.
Nope, I think he hit the hang up button.
Uh-oh.
He just dropped off.
Oh, okay. Yeah, I'm not, like I say, if we manage to teach a class before May, we'll have a bunch of people, or we'll have at least 4 people who
Sorry, I clicked on the wrong. And because Polu has a kit that this is kind of based on. This even has electronics with it, the Zenoh kit that I have.
But what I'm trying to say is beginners, and particularly, we're, like I say, I'm looking at, there's going to be see if I'm right about this, Scott. I think there's 2 groups of people here. There would be one group of people who have built mini robots. They would go ahead, they have no problem buying a new kit and spending money because they're into this too deep. And, and they go ahead and build, a kit to start off with. Because designing a robot to fit 6 inches and weigh 1.5 pounds and have all of the sumo characteristics is not a trivial task. But then we have a bunch of other people who are just, good old beginners who are building, a TTL motor, probably six inch by 6 inch robot that, is more geared we're thinking more geared towards the homebrew robotics tabletop challenge, which if you think about it, it's got the sensors for your sumo. So it'd be, can they make some simple modifications and then have that robot work in the in a sumo class? Now, what I'm trying to say is, what if we said, okay, they could be a little bit heavier, maybe not. I'd have to check that. I don't know if they would be heavier, But most of those things use the micro motors, right? Most of your robots, they're using micro motors.
Well, actually, the tracked one uses the micro motors. Both of the other two, they use just servo motors that have been modified to do continuous rotation.
Oh, okay.
And then this one uses those plastic motors that Palu and SparkFun sell, the little plastic gear motors.
Yeah.
Maybe I can.
Yeah, can you show it? That's a form of the T. I think that's the right
Yeah,
angle.
see the L motors that they sell. You can kind of see. It's hard to tell in there, but you know, there's just those plastic motors. Now I put a different wheel on it, but
yeah. I believe those are made by TTL or TT Motor. I shouldn't say TTL, TT Motor, but those are the ones that have right angles, and they're kind of a different form factor.
Yeah.
So.
So you can use, you know, a variety of different motors, and actually the 500 grams is actually more than you think, because, like, for instance, this one looks like it's, you know, got all kinds of stuff on it, but if you look here, I've got this lead weight in the front to, you know,
bring it up,
provide more weight.
Yeah.
So, you know, really 500, and this one right here, the one I just have been working on, actually the chassis, this metal piece in the middle, I made out of steel just to have it, you know, provide some more weight. And this one's only about 340 grams right now. So, you know, it could stand some more weight on it.
Well, would you be really upset?
To me, that's part of the mechanical challenge, is to meet the size, and really the weight's really not a big issue. Like you've seen on these, I've got all these AA battery holders, and there's actually another pack in the middle. I think I held like 10 AA batteries on these to give me 12 volts. And not that I really needed 12 volts, but that was also part of the weight package as well. So, you know, it doesn't sound like much, but when you start, and you know, the easiest thing with Sumo is to start with a kit, and there's lots of different kits. I mean, all three of these started out as kits, and of course I've tweaked and modified on them, but you know, that's why I was saying, well, you know, it's an easy entry point, because you really don't need odometer. You don't need a lot of really sophisticated software. I mean, you know, I was talking about having different behaviors with a select switch, but you know, that's not necessarily a requirement. So
looking on Amazon and Polulu, it looks like Zumo robots run between 100 and 150.
Yeah, the full kit. Yeah, with electronics, motors.
Right.
And they have like the Pi version. Yeah, I guess I can.
Is he gone?
No,
there he is.
So they have the different versions of the Zumo kits. The Arduino version, and then they have their own little version, which is basically an Atmel CPU.
Is it the A-star one?
So you have the 2040, which is a Pi based, the 32U4, which is the AT Mega based version. You got one that you can plug an Arduino board on top of, kind of upside down. And then I think this is also an Arduino based version, but an earlier version. This one has the updated display. So yeah, I mean, like you said, Paul, and they've got all the sensors. They've got side sensors even, which is not a bad idea. You know, kind of the same thing as my back sensor, but this one doesn't have a rear sensor. But they have libraries of software you can start with. They'll do line following.
So,
And like you said, it's a reasonable entry point. You can get the unassembled version for $100 and do it yourself.
oh, really?
Um,
Yeah, it's 100 to 150. So what about Doug's suggestion of maybe we have flexibility in size and weight to allow really to open it up to people who have a robot that's maybe a little bit bigger, or is that sort of like, nah, don't want to go there? Just asking.
Yeah, I guess what I'm saying is the beginner robots that we probably would go in the build your robot course we're thinking about. Probably, oh God, let me get a ruler, but I want to say they're probably going to be about probably 8 inches by 6 inches or something like that. And I don't think they'll be too bad on the weight. They probably won't be as sophisticated. They won't have as much power, I think, as the 12-volt model that you're using. But I guess the question I would have, Scott, is that something that you would be willing to compete with your robots on those? Otherwise, even though your competitors would be slightly bigger and maybe weigh the same or maybe just a tad bigger, but they're not going to be as sophisticated. What I'm trying to do is see if we can say, okay, we did the tabletop. Now we want to see, because Sumo is fun to watch. It really is.
Yeah.
And so, you got your robot now. It's with minimal changes, you can compete in this Sumo. Now, you probably won't win against Scott, but you'll still, there'll be other competitors that are very similar in build to your robot. So they would, maybe they give Scott number 1, but 2 and 3 they get a chance at. And maybe we say only a competitor can only place in one spot. So it's just up to you guys. What do you think? I mean, I'm trying to see what we can do to get a Sumo in when I know that we don't have very many Sumo robots. So,
well, maybe we just have an Sumo exhibition and not really have a contest out of it. I mean, like you said, it's entertaining. We don't. It doesn't necessarily have to be competitive.
Is Kareem on, or is he? He's not on.
No, Kareem's not on.
I want to say because he has a handful of robots that look kind of like Scott's first robot that he showed. I don't know who makes them, and maybe it was a Pololu robot from back in the day. It's got big wheels, and who would be the other guy? Oh, I know who it is. It's not Pololu. It's the guy that made the basic stamp stuff. What's his name? What's that company? Parallax. So he has a couple of Parallax robots, I believe.
This shows to be a SolarBotics kit, the one that just had sensors on it.
Mm-hmm.
I don't know that they're even around anymore.
Mm-hmm. Yeah, I want to say that. So I don't know. I'm just saying, if we could have an exposition, but it'd be nice to have a little bit of competition.
Well, how about we plan to have an exhibition and see if a contest breaks out?
Okay, that sounds good. I think that's a reasonable, but what I'm saying is, if somebody came with a robot that was 6 by 8 or 6.5 by 6.5 or something like that, would you feel like he had an unfair advantage on you? I don't think he would, but if it would,
yeah, it's hard to say. It's really about weight and traction.
Weight and traction.
But
motor.
I think that's where you separate it between an exhibition versus a contest, because unless you're competing against similar or someone who's really adhering to the rules of that particular contest, and I'm fine with having an exhibition. That's fine. I just, like I said, it's always entertaining contest. and maybe if we have an exhibition, we can generate some more interest. So,
Right. Yeah.
I got no problem with that.
Okay, that sounds good, Scott. So, okay, let's plan on that, I think.
So can we clarify what we mean by having an exhibition versus having a contest? Like in an exhibition, do we still put robots potentially of different sizes in the ring and see what they do?
Yeah.
Yeah, but they wouldn't be grossly. I mean, we wouldn't use like a 12 by 12 robot.
Yeah,
Okay.
I mean, you would.
But
I think
if you're
you would
talking
loosen
about
the rules, but
yeah,
you would
if you're
still have to maintain some sort of equivalency. You know.
Yeah. But I think all the robots that are planned for doing the homebrew robotics challenge should all be close. They're probably all going to weigh less than 500 grams, but possible they might be a little more. I'd have to weigh one. I don't really know, but they're not going to be built to the strict standards of 6 inches by 6 inches,
Yeah,
150 by 150.
100 millimeters. So 10
100
centimeters
meters.
square.
Okay. So yeah, so
It's
they're definitely
just
not
shy
going
of
to be
4 inches square.
Yeah, it's going to be different than 4 inches. I thought you said 150 millimeters. Okay, so 100 millimeters they're going to be substantially bigger than that, but they won't be near as powerful, and they won't have near as much traction.
And so I'm assuming that if we have an exhibition, there's no prizes. It's for fun to show.
Right. It's just yeah.
And so am I hearing that what we're deciding is that if there are robots that comply to the mini-sumo standards from two or more people, then we'll have a competition with prizes. In addition to that, or perhaps in place of, if there aren't 2 people with mini-sumo compliant robots, we'll have an exhibition where robots of different but similar sizes might compete with one another. Did I get that right?
Yep.
I think you summed it up very nicely.
Okay, that's a decision. I like it.
Mm-hmm.
Did you achieve your mission, Scott?
Yeah, I was. Yeah, I didn't have to get too shameless about it, but yeah.
Well, good job. It's fun to do. It's fun to do different stuff. I wasn't feeling like dropping 150 on a robot for one contest, but I'd enter my robot in my little robot mini-bot in a shove around for fun kind of exhibition.
Yeah.
Well, it'd be interesting to see how your little dog bot would do against a wheel vehicle.
I think that
dog, that's cruel.
It could just sit in the middle of the course and howl.
Yeah. As it gets run over,
as it gets
shouldn't play in
pushed out of the
the road.
ring. Yeah.
Yeah, I don't know.
Well, Paul, maybe Scott could sponsor you, give you the 150 to, get the things going. I don't know. Just a suggestion.
Maybe, yeah, or give him one of the older robots that Scott's got up on concrete blocks and give it to him and let him but it looked like he's got them all ready to roll.
Yeah.
I don't know. There's something a little tilted on one of them. So
now these 3 here haven't even been powered up in at least a decade.
Yeah.
And in the development environment for the microchips, I don't even maintain anymore. So, I mean, I'll put batteries in them and whatever they used to do, hopefully they still do. Really, the one on the end here is the only one I'm really seriously working on.
Mm-hmm.
So, it's just, I kind of like the look of it. And when I put the front blade on it. I'm like, man, that's like a dozer. So that's why I called it D9. Although I think D11 is the bigger dozer, but I just like D9 better because it's more like I'm going to D9 you of a win.
Yeah.
Okay, so I put
Years ago, when we had a robot club here in Colorado, we had a mini-sumo contest, and I built one, and it was a fun contest. Easy to program, once you have the kit built, it's fairly easy to compete, and it's a lot of fun. And if you have some sort of line following or other contests, they'll work great for that too.
Yep.
So somewhere I've read that for some of these sumo contests, they'll have actually a metal playing field, and the robots might be outfitted with magnets to give them more traction. So I was wondering about that, and the other thing I was wondering about is the other way to get traction, which would be to have an air suction to pull you down towards the surface.
Both of those, if you get the book, what is it, Building Sumos, both of those techniques, the metal plate is standard in Japan.
Okay.
And that's it. That's a good book. It's and you can get it on Amazon for used.
They do that typically on the more battle, because there's kind of two. There's an autonomous version versus an RC, more of a battle bots version of it. And yeah, they use all kinds of things in those contests. I went the one Sid Vicious here went to California and participated in the Robo Olympics. I think it was in 2004, I think it was. And the teams from Taiwan and Japan just kicked my ass. I mean, their robots were so fast, and they had little it was almost like shim material with double back tape on it, and they would kind of tweak it and bend it so that the robot actually scraped against the cores, and you could literally get up under anything. Even like something like this, they had it so thin and sharpened, and they would change them out after every couple of contests because they would start to get dented up because they were really thin. I mean, they had sensors all the way. They had 360-degree sensor, so no matter where you went, they would just tweak it, boom, and their robots were just so damn fast. The match, I think my longest match was about 2.5 seconds. And that was only because I had turned on my defensive, so I tried to avoid them, and I lasted 2.5 seconds. So
run away.
Yeah.
Okay, well,
here's a good book. If you can probably get it out of the library. It's called Robot Sumo, and I believe it's written by a guy from Seattle who was part of the SRS, and he was really, he was, he flew over to Japan and competed, and let's see.
Did he last more than 2.5 seconds?
Yeah, I think so. This book is, a lot of it will be, since it's written in 2002, a lot of it is out of date when it talks about processors and whatnot. But when it talks about the mechanical building and the programming and whatnot, it's pretty right on. Anyway, like I say, you can probably get it out of you can either get it on Amazon used for probably $1 or $2, or you can probably get it from your library.
Hey Scott, if yours only lasted 2.5 seconds, how long did the the competitors last?
You mean the guy that won, or?
Yeah,
there was a couple of,
if the two better competitors were in a heat, how long did the heat last for them?
Typically, there was a couple of teams from Taiwan, and there was one team from Japan, and they came in first, second, and third, and their matches were really pretty fast. I mean, it was whoever kind of got the upper hand or who identified them first. The robot from Japan had the sensors that were 360 degrees, but it was a much more bulky, big, gainy like robot, more like here where you have, you know, a lot of vertical height. That both teams from Taiwan had little machined metal wedges that the one from Japan had a hard time picking up. So the teams from Taiwan actually won first and second, and then the team from Japan came in last or third place. I mean, I probably came in last, but
So they still just lasted seconds.
yeah,
these
I mean
teams.
the competitions were really quick because of the capabilities of the robot.
All right, that's an interesting calibration because I'm only used to seeing when we've run for the middle schoolers, and those can draw out for a while.
Yeah. But you're talking about extremely fast robots with good sensors.
Yeah, right.
And yeah, so it's just a matter of once they identified where their opponent was, the match was pretty much over.
Yeah.
Wow. Okay. Well, thanks, Scott. Jai is ready from Iron Rain, so I want to suggest we insert him here so he can go off and do real robot building that hopefully will help them win the competition. Jai, you're up.
Hello, can you guys hear me okay?
Yeah.
Okay, first off, I want to thank y'all for letting us kind of slide in. Yeah, so I have a kind of more software focused presentation. And yeah, my audio and my camera are on 2 different devices. Sorry about that. But I have a bit of a more software focused presentation. I missed the smart camera panel that was at the in-person meeting. And I kind of wanted to share what we had to show. So we were taking a look at the Limelight. And so what I have here is I have a kind of a short presentation Limelight and then a little demo as far as how we're using it in our competition this season. So I'm going to go ahead and share my screen. Window. Too many buttons. Okay, slideshow. There we go. Okay, so okay. So essentially, the Limelight is a smart camera that's I think it's the only FTC legal smart camera, and so especially last year, I think I may have come on here and complained about how slow our control systems are because we're limited to essentially a small Android phone worth of compute power, and it's not the best to run any kind of vision pipelines on. And vision pipelines are really useful in the game because they give us a sense of where we are, because especially this year we have April tags around the field that we can derive some kind of position from. And so the Limelight is kind of a beautiful solution to all of these problems. So it does all of its processing on device. And so we take little to no performance hit for our control system while it's running whatever pipeline you want. It has built-in kind of relocalization, and of course it's FTC legal, which is a big plus for us. So it does have a pretty sick feature set. It has a built-in way to put in where the April tags are in the field. So they have their own field map format that you can build a virtual field in, and you can position April tags around, and it'll handle all of the reload. I'm also going to kind of walk through the web config menu, and so it'll be a lot clearer then. But yeah, the capabilities we have right now are color blob, sample detection. Sorry, samples are these yellow rectangular prisms, And these are kind of the object that we need to manipulate during the game. We need to pick these up and put these in baskets on the field. And then we also have these April tags that are, again, are positional on the field for relocalization. As far as the specs for it, it's pretty small. I don't want to take it off the robot, but I can do this. So that's, let me rotate my camera. There we go. That is our Limelight in the context of our robot. So Jay's hand for scale.
I didn't see that. I didn't see the actual picture of it. I see your presentation, but I didn't see what window is it in?
It's in.
It should be in Anuya Das. It's a separate person who joined. I can stop sharing if that helps.
No, wait a minute. I just gotta find her or him. Sure. No. Anyway, this sounds a lot like a Pixie. Is that about what? Sounds like that's about what you got. Oh yeah, I see it now. I see it.
Sweet. Okay. So yes, my hand for scale. It's pretty sizable for a smart camera. And then I'm gonna start sharing again in a second.
Now, is this an AI camera, or is it just a blob detector and an April tag detector, or is it OpenCV friendly, or is it actually run neural networks?
It's a full AI camera, so it does but it's not accelerated, like it doesn't do TensorFlow, any of that.
Okay.
But it does have I think it has object detection, color blob, April tag, all of those.
Okay, so it's a little bit like a Pixie. That's what it sounds like.
Yeah,
Okay.
like a really overkill Pixie.
The
Okay.
key differentiator that for me at least, came out of the smart cameras discussion at the last meeting was, does it have an ASIC dedicated to AI and vision processing or not? Or is it microcontroller based? Because there seem to be 3 tiers is what really came out for me out of the discussion. At the bottom tier, you had microcontroller based like ESP32 cam. Middle tier, you had, which we didn't really talk about much, but you had things like a Raspberry Pi doing AI processing. But then the most performant cameras were the ones that had an ASIC, a custom ASIC that did vision or AI processing. Can you rank it in that space?
It is just a microcontroller, so it doesn't have an AI accelerator, right? It is just a microcontroller, but it's a pretty capable microcontroller.
Okay.
Yeah.
It's like a Pixie, Paul. Otherwise, it has the ability to do blob detection. It might be a little more it's probably a little more sophisticated than the Pixie, but Pixie can do. It doesn't. I don't think it does April tags, but it can do something similar to April tags. But so if you got something that was designed to, I mean, that's what it sounds like. It sounds like another variation of about that same thing. It's also a little bit faster because I don't think. I mean, it says 90 frames per second. That's pretty damn fast.
Yeah, but
so
further down you showed it said it easily did sub 500 milliseconds. That's only 2 frames a second.
That was it was really like choppy the first time. That was pre-tuning, any kind of experimental testing.
Oh.
It's probably much faster, but that was kind of my safe estimate. Very safe estimate.
Oh, okay. All right.
But I can say for color blob and April tag, they're 50, 60 frames
per second.
probably. Yeah.
Okay, yeah, that's more realistic.
yeah.
And it can do TensorFlow and other kinds of AI pipelines. You have to train it, and they've got a workflow for that. But I think those are typically dropping down to about 20 frames a second.
Okay. So, so, and it has no accelerator in it?
Couldn't look it.
Now,
Yeah,
the
no,
quad,
I have to admit that a lot of these new ARM chips are STI. It's got a lot of a series of chips that it's made that I don't think it's really truly accelerated, but they have their vision friendly. I'm not sure what the right word is. They're moving that way. Okay. All right. So this is not competing with something like like an OD Lite. It's not quite there yet.
Right. It's got fast onboard
Control.
microprocessor.
Yeah, it's got an A672 Cortex. Yeah.
Is that like Raspberry Pi 4 or 5 level?
I don't know. That's a good question.
Yeah.
Billion operations per second.
Okay. Well, thank you. You kind of placed it in that spectrum, Jai.
Yeah.
So yeah, carry on.
Go on.
Yeah.
Yeah.
Okay. So now I'm going to shift to kind of a demo. So what we have running right now is basically turn it around to our robot. And so, yes, this is our robot. This is
Wait a minute.
Poseidon.
Again, I've lost it again. Why is that not showing up?
It's in our ROS.
and showing here.
Sorry, this should bring it to the top.
There it is. There it is.
Sweet.
Okay.
Okay, so this is Poseidon, and one of the capabilities of Poseidon is this whole flow, where it'll send out an arm and pick up one of these samples, just like that. And so if I take this out, and we have the Limelight right here, what I can make it do is track where those yellow samples are. So, if you want. So right now it's tracking basically just those color blobs, and I can kind of have it follow this this should really only be used for like auto correction, but it is a pretty cool capability, and this is something we couldn't do before because nothing before with it was this performative. Like right now, our pipeline is running at I think 40 to 50, just 45, 50 frames a second right now, and I think it's just fun to bully the robot around. And on the code end, this is just a PID loop that's taking in where the color blob is within the field of view. And it's auto-correcting. Of course, it still needs to be tuned, so you have some of that pick back. But this is
I have another question.
And right now, I have it set up so that it aligns perfectly, and I can initiate this whole sequence, and it'll pick up and
I have
be
a
ready
question,
for
Paul.
whatever we want to manipulate.
I have a question.
Yeah.
Take your yellow block and put it down on the course. And now put four more other yellow blocks. What does it do then?
It takes the biggest color blob, so it depends on like if they all end up being detected as one blob, then it's kind of at a loss. But if we do multiple blobs, like let's say one farther, one middle, it'll probably track this one because it has the biggest blob.
Okay, move it so that it'll have to track it again. Okay, go drop it.
Oh wow.
And then this one shouldn't affect it. Same thing with this one.
Wow.
Okay, cool. Now, how is it? Is your picker upper capable, let's say you put one behind that one. Yeah,
Just like that?
what does it do? Yeah, what does it do? It
So-
still ends up picking up one. Okay.
Yeah, it only ends up picking up one. Unfortunately, we're not allowed to pick up more than one. So
No, that's
it's
fine.
kinda-
I just wanted to figure out if you had two real close, would it cause the arm to screw up? It looked like it did fine.
So yeah, that's kind of what it looks like in action. And of course, this is only the start of the capabilities. We do have an April tag pipeline that I have if I stick an April tag right here, and actually, I don't have a nice, neat way to show that. But this is kind of the start of what we can do with this.
Mhm.
You can describe what your April tag pipeline does.
Right. So basically, here, right now I can set it to track April tags, and so it won't move based on it. But right now, April tag in front of it. Let's say I think this is the one that's supposed to go on a wall right over there, and it'll basically snap its position, its knowledge of where it is on the field based on where that April tag is. So this is, yeah. And they're pretty seamless switching, and it's super, super fast.
Mhm. Neat.
Neat.
And then I have one final thing to show, and that's what it looks like to configure one of these. So I'm gonna kick off this camera view and switch to a different device. Give me 1 second.
Pick up on your laptop.
Yeah. Okay, so I'm gonna go ahead and share my screen. So this is what the config looks like for the Limelight. So I think it's still booting up, but it's a really nice, neat web pipeline. There's really no code in the solutions that we have so far. Just tweaking a bunch of values and letting it threshold. Still waiting for it to boot up. There we go. So you have a kind of view of what the Limelight's seeing. So I'm going to shift this away from me and set a. So this is what it was based. This is what it was basing its knowledge of the yellow blobs on. So you have that color blob pipeline, and then we have the April tags. Oh, it's seeing the one all the way across the field. I'm gonna turn the gain up for the humans in the call. You can just barely see there's an April tag all the way at the other end of the field that it's picking up on, and we're actually getting a robot position on the field using that. So it's saying the tag is somewhere over there, so we're somewhere over here. And of course, this isn't the best relocalization because we're so far. But it gets really, really good when we get closer and closer.
Wow.
So you know that position based on the size of the tag in the field
Yeah.
of view?
Yeah.
Yeah.
Wow.
So again, this is another capability that I wish I could showcase, but it's actually mounted on a servo. And so we have it just rotating. And so I can actually just drive that servo right now. But we have it kind of spin around based on what we want to look at. And that's also controlled within the code to kind of, let's say we swivel around and want to check for April tags anywhere in our field of view. We can do that.
So
And yeah, we're just scratching the surface.
the camera is on a servo, is what you're saying.
Yeah.
Like a pan.
Nice.
Mhm. And so that's kind of what we've done with the Limelight so far.
Yeah, that thing's pretty expensive. It's $189.
Yeah. That's higher. That's more $50 more than a OD light. $189 more than the pen sight. But like you said, this is legal in their contest. The question I would have: what made Kareem? Do you have any insight into what made this particular tool legal? I mean, was it, the guy gave him so much money under the table, or what?
So, FRC is the the big boy robot. They're larger and they have bigger teams and things like that. And they've been running with it. I don't know the origins. But they've had these Limelights for a few years now, a couple of different versions, and they have some that are accelerated with like the Google tensor processor. But this one was specifically reformulated for FTC. This is the first year it came out, so they already had a relationship with the national organization, and I don't know how that formed.
Okay.
All right.
Well,
Nice
cool.
job, Jai.
Yeah.
Gold star for Jai and Iron Rain.
Yeah.
Work. Thank you for
Thank you guys.
Thank you for presenting that, Jai. If you would be kind enough to send me that slide, I'll get it integrated into the slide set that belongs to our presentation or to the smart cameras panel.
Yeah, of course. I'll send it over. I'll probably put it in the Discord.
Yeah, that'd be fine.
But
Cool.
thank you for having us. Thank you for listening to my presentation.
All right. Thank you. That was interesting. And that is a heck of a robot that you've got. That is
Thank you. Thank you.
one complicated and sophisticated beast.
Yep.
Okay, Ted was up next.
Yeah, okay. So I'm still doing some experiments with my GPS modules. I've still got them mounted the antennas right next to each other. So getting two values, and I will present my results here. I decided to take a lap around part of my backyard, and so that's what I'll be showing here. Let's see. What is that? There it is. All right. Yeah, now can you see my mouse at all? Oh, wait. Oh, there it is.
Yeah, I see it.
Yeah. So this is where I started. This is what I marked as 0, 0. And, I didn't spend that much time coding it up. I just put some code on an Arduino and took the UBX interface location values. So this bottom one and the top one are the two GPS antennas, and then the middle one is the average. And for some reason, it's dropping out in certain places here, which again, I didn't spend much time coding it up. So I started here and started walking this way. It didn't start recording till here. And so I walked around like this. Actually, everything kind of came together about here and then spread out some more and then came together down here. And then I walked up here and finished recording. But the interesting thing to me on this is that even though, the specs are like plus or minus 1.5 meters, which is probably in perfect conditions. So it's more like 2 to 2.5 meters. But, if you're just going for a short time, it gets fairly consistent results, and it more or less drifts and gives a random location in that error ellipse. But yeah, so you can see here, and I went and kind of measured it, and it was drifting about 1 inch per second I think this whole loop took me like 40 seconds or so. This is about 42 feet and then 12 feet this way. So yeah, I thought, you know, it's not as bad as I was initially thinking with a plus or minus 1.5 meters when really it's a lot less than that short term. At least you can get good relative results. You know, you can see these are two fairly straight lines here, and that's probably about as straight as I was walking anyway.
Ted,
So yeah, that's all I had. Just a little update with the
Okay.
experiments I did this weekend.
Ted,
Ted,
do you know how many satellites were in use during this test
It was between 27 and 30.
that were in use?
Yeah, that's what the GPS was reporting.
Oh my goodness.
So let me ask you this, Ted. I missed part of this presentation. So you have two GPSs. Like, what do you mean by two?
So-
you have one on set like 12 inches apart or something? What?
No, I bought two of the SparkFun Max M10S modules, and so
Okay.
they're U-blocks. They're fairly new chips, and I mounted the antennas. So they have external antennas. I mounted the antennas right next to each other on a steel plate, and so they're about probably 1.5 to 2 inches center to center, and just walked around my yard with them. So last week I was I kind of gave a little report with some graphs showing how the two antennas were picking up different satellites at different times and dropping them at different times. So they were just kind of drifting up and down randomly, you know, drifting around randomly, but in different phases and stuff. So you couldn't really use them for any sort of differential readings. And Tom suggested maybe we try to tell the GPS units which satellites to use, so they'd be using the same satellites, which seemed like a lot of work to me. But I think I'll just use them this way. And so then I was kind of looking at taking the average of the two antennas, and it does seem like you get a little bit better results doing that. But it seemed to me like just kind of looking at the data that it might have shrunk your error circle by 10-20%, but not a whole lot.
Do you have any thoughts on why two identical antennas and receivers would be different from one another by as much as 4 meters vertically?
Yeah, and I think it's just because they're picking up different satellites. So when there's well over 30 satellites to choose from, and I don't really know how many satellites to choose from, but if they're using around 30 satellites each, there's probably a lot more up there to choose from, and they're just picking up some and dropping others off. If you've ever watched how the GPS antennas do that, you can see satellites coming on and then leaving.
Mhm.
So I think they're just picking up different satellites at different times.
Oh,
Yeah, that would be my guess as well. I'd agree with Ted that it's got something to do with exactly which satellites it uses at any point in time. That's why I thought, what if you just told it, just use these 8 satellites and nothing else and see what happens?
Yeah.
wow. That's fascinating.
Yeah,
I think I missed
would have
something.
thought
Did
they'd
you
have
say
been
that they were happening at the
not.
same time?
Say that again.
Did you say that you were running them at exactly the same time? Like
Yeah,
it's not
so I was
lapse?
recording both of them at the same time.
Okay.
Wow.
So is the purple in the center, is that the average of the two?
Correct. That's the average.
Okay.
Which when there's two, it's not that interesting because it's just the middle, but there you have it.
Yep. Hmm. Okay.
Wow. It's
Does
kind
that
of-
face like in a certain orientation is it, north, like on the plot, or
Right.
east
So
west?
this map, north is up. It's basically a map. West is left. And I
Okay.
converted the latitude, longitude to feet. So those are feet is what you're seeing the scales.
On the scales, okay. Yeah.
ah.
Ted, the actual antennas you're using, are they symmetrical or are they longitudinal?
They're those little square patch antennas that are about an inch square.
Yeah,
The
okay. So
$12
and
one.
you've got them mounted in the same orientation. The wire comes out the same side on each one.
Yes. Yes.
Because they're almost symmetrical. I read a research paper on them. They're almost symmetrical, but not quite because of where the connections have to be made. But if you've mounted them in the same orientation, that's not the explanation.
Yeah. I might have to mount them in different orientations and see if it makes a difference. I doubt it though.
Good point.
It's interesting that if you could draw a line from north to south, and they seem to converge on that line where they're, on the top, at right near the gap, they're all together.
Right. Yeah.
And
It
then right
seems
where you started at the bottom, they're all together.
Yeah.
And
And this pat is actually where I finished. I didn't get the first few seconds of recording, so I just walked around the corner. But
yeah,
it was
But
a
they-
lot more spread out at the start, and then it converged together at the end. So
Okay.
yeah, it seems that for some reason it must be the geometry. The east-west sides are they're further apart, north and south.
Ted, is your sky view the same everywhere in your yard? Or do you have houses or something?
No,
around?
so my house is right here on this line. So that might have something to do with it.
Oh.
And you
So
have
that's like
neighbors'
your
houses
backyard.
as well?
Yeah, so there's nothing, this back part is an open space and there's not much back there. There is a tree on this corner here.
Okay.
And a fence over here. And the fence out off the end several feet this way.
Yeah, okay. Doesn't sound like anything unusual. Whenever the sky view changes, it changes for both antennas.
Yeah.
There's also we look the average between the two readings is perhaps a little misleading in this way that the GPS is supposed to be accurate to 3 meters or so, 2 to 3, and it doesn't tell us whether both could be tracking 2 or 3 meters off.
Yeah, it doesn't tell us where the truth is.
Right.
And really, this, as far as I could get from Google Earth, which is, maybe a foot, this is 0 is right here. And it's actually, 3 feet this way, it looks like. And a little bit south, maybe a foot or two south. So this is really 0.
Oh.
Yeah.
When it was recorded as about -3 feet west and about -2 feet south.
Yeah, something like that.
When
You said there's a fence back there. Is it like a barbed wire fence or a mesh
No,
fence?
just a wood fence, kind of a privacy fence about 6 feet high. And it's
Okay.
probably from this, it's straight this direction, maybe 10, 12 feet.
Yeah, I was thinking maybe what's the quarter wavelength of GPS signals, and You know, do you have regular?
Yeah,
Very, very small.
it's wood though. The fence is wood.
Not likely, but
It's interesting the way the, I don't know what color that is, purple line on the bottom right kind of veers off to the right, almost goes horizontal, while the green one keeps on tracking. Yeah, there. Whereas
Yeah.
the green one keeps on tracking. That's really interesting.
Yeah, and just watching the GPS drift around with the units, like just keeping it in one place. Often one of the GPS readings will start to drift one direction and the other one might stay the same.
So the GPS, I'd understood that the drifting was caused by the ionosphere shifting around, and that the fact that one of them drifts and the other one doesn't, even though they're both side by side, supports the idea that they're using different satellites in different parts of the sky that
Exactly.
are receiving different distortions due to the ionosphere shifting.
Exactly.
Yeah.
That's really
That's why I
interesting.
thought it was important to make sure they were using the same satellites at the same time in order to avoid those different paths for satellites.
Yeah.
But
Yeah,
that's
I'll have to dig into
complicated.
I'll have to dig into the U-blocks and see if I can find more information about which satellites it's using and what's available.
And maybe you can say to use only GPS, not Baidu and Galileo and
Or vice versa.
Yeah,
whatever.
The Baidu satellites apparently are better than GPS now.
Very
Yeah,
interesting.
anyways, that's why I had to report.
Thank you. That's
Yes, Ted, thank you. That's always useful.
Yeah, cool.
a little dismaying, but
Yeah.
but interesting and valuable. Thanks. I guess I'm up next. So I had an interesting excursion into Ross land, specifically Ross comms land. I've been looking into Zenoh, and I'll talk about what that is here in tech. But basically, in December, I swapped out my home network router for a mesh routing system from Eero, the Eero 6 router, and it absolutely does not seem to do multicast at all, which means DDS just plain doesn't work. So since about mid-December, I've been unable to get my laptop to exchange ROS messages with any of the robots. I can SSH into the robots all day long, but can't get ROS messages to go through, even though they're on the same network and in the same room, so presumably connect to the same mesh node. So there's been a move afoot in the ROS community to replace DDS, because really what causes this inability to communicate is the fact that DDS absolutely relies on multicast to discover nodes on other hosts. And so this is a drawing of the ROS comm stack. You've got the ROS C library for CPP, RCL CPP, the ROS C library for Python, RCL Pi, and for Java, that has the interface that user nodes talk to. It makes calls into the ROS C library, which is a C API that provides primitives for implementing actions, parameters, names, console logging, etc., to any of these language-specific libraries. And below RCL is the ROS middleware layer, which has a C API that exposes a consistent interface from the 3 supported DDS implementations. And but DDS has some problems which I experienced firsthand myself due to my router change. I experienced it. Various folks in the ROS class that I led last year experienced it. Discovery issues, apparently has payload issues, containers, firewalls, and VPNs that definitely just are unfriendly to, can be unfriendly to DDS. And those challenges are inherent to DDS. So what's been happening in the community, and there was a paper on this at the 2024 ROSCon, is taking a different transport layer, getting rid of DDS and taking a different transport layer, and they decided to use something called Zenoh, which is a I think they call it zero network overhead. Is that what that is an acronym for? And it plugs in where DDS plugs in the previous architectural diagram, and uses a library to expose the API. So effectively, if we go back to the architecture diagram here, RMW Zenoh plugs in at this level in place of RMW above DDS. And then below RMW Zenoh is the actual Zenoh transport. The Zenoh transport is something akin to something like MQTT, or there are lots of those other transports. Here's a list of some of them: TCP ROS, OMQ. I don't know what these other ones are, but anyway, it's not important, because what Zenoh, native Zenoh, contains is peer-to-peer communications and peer-to-router communications, and then router-to-router communications. So communications can hop through peers to a router, between routers, and down to remote peers. So it really has a distributed topology, not unlike DDS, except that DDS doesn't have this notion of routers. Everything's a peer and discovers, and they all discover each other in DDS. So it's similar but different, I guess, maybe I'd say. So these slides are from the talk at the 2024 ROSCon talk on RMW Zenoh. So what they do is each host has a router, and then the nodes talk to the router and amongst each other, so they can communicate directly to each other. And I'm not sure if the router participates in nodes on a host discovering each other, but the router definitely participates via the other router on a different host in nodes on one host discovering nodes on another host, so that all hosts can do publish and subscribe, and it's all as if they're on one happy network. So that's what the ROS RMW Zenoh initiative is about. And so essentially it's, to a fair degree, a drop-in replacement for DDS that overcomes those issues that prevent DDS from working on certain Wi-Fi networks, and have a bunch of other problems. And so I've been testing this, implementing it. They've actually put out binaries that you can download with apt install for Jazzy. So I've upgraded my laptop to 2404 running Jazzy, and the robots also, and tested that they can actually communicate to one another, only using the talker listener, send a message once a second. So haven't really tried anything more sophisticated, higher data rates as of yet. But at least they will now talk between hosts, which was something I couldn't get to work using DDS as a transport. So that was great. And I was very happy and very excited. And I'm working with the Lino robot stack and trying to get my little robot to run ROS2 on the Lino robot stack. And so I thought, how hard can this be? Lino robot uses, so let me uses micro-ROS. It runs micro-ROS on an ESP32. Other microprocessors are supported. Microcontrollers are supported, like I've lost some of the names. RP2040, I believe, running on an RTOS. And so I thought, okay, well, this is talking ROS. You can have microcontroller calls to create a publisher and subscriber and send ROS messages over into the ROS stack and have it talk to the applications over on the ROS stack on the laptop, like RBiz, for example, or path planners. And this all looked like it should work. Well, I haven't got as far as making all of that stuff work together, but I thought I'll just plug in Zenoh as a transport in place of DDS, and no go. So I filed a ticket on it and had an interesting discussion with a couple of the support people, and the keeper of the micro-ROS source code. And it turns out that this micro XRCE DDS client that talks to the ROS2 agent inside of the ROS stack on Linux, I guess it depends on having DDS at the other end, because it plain won't work if you put a Zenoh transport underneath it. So that was my moment of deflation. My wonderful idea of using Zenoh to let my laptop talk to the Raspberry Pi and have the Raspberry Pi talk serial to the ESP32 running micro-ROS is out the window.
If it ain't one thing, it's another.
Yep.
And Paul, you maybe I missed something, but it seemed like you were saying that your router change was the key problem that caused DDS to break.
Correct.
Why wouldn't you just set up another router in your house?
I may well do that, Doug. And when I want to run the robot, switch to that router's network.
Well, just have it. I'm not a routing expert, but I believe you just run the router on as a subsystem or a subnet, a submask.
Yeah.
And you so it could be running all the time. It'd just be something else.
Yeah.
Okay.
That's probably one of the things I'll do. Another thing I'll do is micro-ROS can apparently talk over Wi-Fi from the ESP32 to the ROS2 agent. No, that's still not going to work. Yeah, that would at least let my laptop talk directly to the ESP32 without the Raspberry Pi being in the middle. And there's evidently also a bridge between Zenoh and DDS. So it's all a mess of networking is, I guess, what I'm reporting here.
Mm-hmm. Yeah. That's an interesting idea. What if you put an ESP32 on both ends? Would that allow you to solve the transport issues between each other, the robot and the router?
I don't think so, because the micro-ROS is configured to talk between a microcontroller and a ROS2 agent running inside of a full-blown ROS2 stack on top of DDS. And it's the on top of DDS part that I didn't realize. And I honestly don't think that it needs to be that way. And okay, I'm going to throw a rock here. I may not be entitled to throw rocks, but it was bad enough that DDS is such a mess that it doesn't work in so many configurations. But then when what they could have done, I would think, is to take this RMW interface and bridge it over to in the architecture layer, in the architecture diagram, to bridge it over to this RMW layer here, so that it didn't matter whether you had RMW Zenoh or RMW DDS with Cyclone DDS or any of the other DDSs. The thing that the micro-ROS on the microcontroller should have talked to, in my rather humble opinion, is it should have plugged in at this interface to where it would be independent of the RMW layer. Instead, it appears to depend on stuff that's down here at the DDS layer. So that's a disappointing thing for the architecture, and the architecture is difficult to change, and this is not going to change.
Yeah.
So that's my tale of woe. That's all I've got to report. Rather sad about it, really. But as you pointed out, Doug, I've got other options, like using my old router for the robot, to get a robot on my laptop to use the old router when they're within range of the old router, and but it doesn't really get me onto like cellular connectivity, which I'd need Zenoh for, and some of that fancier stuff. So, or maybe a bridge, or I don't know, but it's a messy network situation. So that's my tale of woe. Sorry for crying on you guys' time. Be warned, software is never as simple as it looks. Okay, next up with Ray.
Yep. Okay, I took a cue from Tom and really started looking at the Openbot stuff, because I was always kind of intrigued by Kareem's use of, cell phones to control robot platforms, but never got into it before this. And this looked like a pretty good opportunity. There are a couple weird things that I found though in the, let's see, did you pin me? Okay, let's see if I can.
Yes, someone pinned you.
Oh, okay.
I like this practice we've started this meeting of pinning whoever's presenting.
Screen.
I think Mark's handling that mostly today.
Okay. Let's see if I can get this up. Can you see the
Yep.
That on the screen? Okay. So the Openbots, it looks like you've got a choice of two processors, either an Arduino Nano or an ESP32. And I kind of focused on the ESP32 because it's, I don't know, just a lot more sophisticated processor and does a lot more things than a Nano can do. And I found some things that are a little concerning here. Let's see if I can zoom in. Let's see, that's 1 of 8. 8 of 8. Okay, so one of the things that you can do is you can pick what the model was. And they had, like if you look on the, let's see, where is it? Research. Whoops, wrong one. Must be this one. Okay, I'll just do it again. Anyway, so if you look at more details, one of the first things it covers is the RTR. It stands for Ready to Run with TT Motors, and there's also a Ready to Run 520. And these both say they're on Amazon, but if you go to click on the link and look at the Amazon page, it says currently unavailable. So apparently you can't buy the kits anymore, which I'm not certain if the support on it faded or they just manufactured so many kits and sold them all or something. But so that was a little disappointing. Anyway, one of the things that, like I said, that you can do is choose between the two processors. And if I go back up to the top, these are all the different processors and options that you can choose. So there's just a straight do-it-yourself version, no PCB. Apparently they offered 2 PCBs that actually used, a Nano, which is based on the Atmega 328P. So let's see, I think, yeah, okay, so these models, they're ready to run TT2, ready to run 520. I think this stands for multi-terrain vehicle, or just you make your own DIY with an ESP32. So that was the one that I was interested in. And so one of the things that I found, okay, so they get into pin assignments here. And some of these pins have dedicated functions on an ESP32. Like if one of the common layouts, this is a 38 pin, it's referred to as a node MCU-32S. And if you look at the TX0 and RX0, which are pins GPIO 1 and GPIO 3, which he's listed here as using 1 and 3. those are actually the TX and RX0, or what's connected to the UART to USB device, and don't think you can do that. So so that was one of the things that I found. The other, let's see here. Oh, it's not in this one. It was in some of the other ones. Supposedly, you're not supposed to use like GPIO 6 through GPIO 11 because that's actually connected to the flash. So those are kind of dedicated. And one of the other ones that actually used, I think at least GPIO 6. So it doesn't look like the ESP32 code was really tested, because I can't see how that would work. So that was the one thing. The other thing was the fact that you can't get these anymore on Amazon. So I don't know if anybody else looked at these. Oh, I was able to load the, they have an app that you can load on your phone, and that seemed very straightforward. They gave you a QR code to scan, and it was pretty simple just to install it. So that all worked okay. Anyway, get back to the main screen. So other than Tom, has anybody else looked at this or played around with it, or no?
I've seen it, and I was always curious about it, and it seemed like a neat idea to use the Openbot, to use a cell phone as the intelligence and the camera, and it's been around a while, and it looks, I was just looking at the GitHub, and there are commits within the last 3 weeks, and issues that were filed as recently as late last year. So it seems to still be active, at least to some degree.
Yeah. Well, that's good. That's unfortunate. Tom stepped away. He was the main guy that I wanted to ask questions to. He's back.
Yeah, another thought too is, the ESP32 has more versions than Carter has pills. And, and some of them, like the flash, you might get some that don't use those flash pins because there's no flash.
There's no flash, right?
Yeah, right. So, so there might be, it might work for a specific module. It'd be neat if you could figure out exactly, if they would tell you exactly which one they used. I mean, it's not like an Arduino. An Arduino is an Arduino is an Arduino is an Arduino.
Right.
But on ESP32, there's there's S1, there's S mini, S2, S3, C1. I mean, it goes on and on and on and on and on and on and on.
C6.
Yeah.
I would guess from the age of it and from the fact that they did not specify the model details, it's probably an early ESP32. A plain 32, a 32S. I'd start there if you have one. You may not have one.
I think mine are, let's see, mine are S3s.
I think that's a very common one that's recommended by, I think, Random Nerds too. I think he uses typically an S3.
Yeah.
Since the guys who developed that Openbot started about 5 or 6 years ago, and the S3 didn't exist then, so they probably didn't.
Yeah. So I mean, you're right. You're right, Tom. That's it's probably true. You sure it's not an 8266?
I haven't seen any references to it, and even in the code, they flag ESP32. Not
okay.
Yeah. So, Anyway, and the one that I use is, it's got battery back, and it's not the the 38 pin version. It's the 30.
Three.
I think it's no, it's
Yeah,
not
there's-
33. I think it's the 30. I'm going to say, yeah, it's the 36 pin version because it's got 13 pins on the side.
Okay.
So
Yeah,
That would make it 26.
oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30. Yeah, it's 26. You're right. Versus the 38, which is,
mhm.
that has like, the, now let's see, what is it?
Yeah, mine's are 30s and 38s. So
Oh, they are. Okay. Yeah.
Yeah.
This one was kind of nice because it ran off a battery. So, and it doesn't bring out any of the pins that are dedicated. Like it doesn't bring out GPIO 1 or GPIO 3, or GPIO 6 through 11, because those, I think this one does have flash on it. Anyway, so it's a little disappointing to see that. It's going, okay. I don't think I've ever seen.
So Ray, the biggest conflict that I heard you express was the use of the serial pins for motor control. But if I'm reading the stuff right, it doesn't actually rely on the serial pins, other than obviously to program the thing, which it goes into a special bootloader mode, right? So
right,
use them then. So is that really a showstopper?
Well, it looks like it does do. There's a debug mode, and it looks like it uses prints to the serial port. So yeah, does look like it's using it.
So it uses the UART0 to communicate to the programming port for debugging. And
Right.
I'm not sure which one it uses to talk to the smartphone, whether it's the same one or a different UART.
Oh, I kind of get the impression it's the same one because you hook the phone up to the ESP32.
Yeah.
So
To the USB port.
yeah.
Yeah.
Yeah, with like a C2C, short little connector. Yeah, so it was a little disappointing. It looks like there's been a lot more attention paid to the versions with the Nano on it.
The GitHub is still current, right? See,
As far as I know, yeah. Paul said it was
make an entry in the query section for the GitHub and see if anybody replies.
okay. Yeah, it's like, okay, how could this work?
I've got this device.
Yeah. Okay.
So the most recent commit was 3 weeks ago. The most recent issue was filed in October last year, and before that in August last year. So not a lot of activity in issues.
Yep.
Paul, what was the commit comment?
There was firmware was fix wrong right RPM on the OLED display.
Yeah, that's another thing. They have Adafruit doesn't recommend using an OLED display with the 328p or the 32U4 because it doesn't have that much memory, that much RAM. So I think the OLED displays take quite a bit of RAM, so you're not going to have enough for variables and stack and everything else. So I was kind of surprised to see that, and I don't see any communication beyond setting up the OLED. So it's like, okay, it's there. The code doesn't use it at all, so kind of thing. So it's like, okay, so maybe that was an afterthought or something, but so that was, kind of like another flag. It's like, okay.
Depends which driver you use with an OLED display. If you're attempting to do fast updates and not watch the update happen on the screen, then that's why there's a dual copy of the data in RAM. But lots of drivers don't work that way. It's treated as an output device, and what goes out, and it doesn't work. So you don't have to use the fancy drivers.
Yeah, it looked like they referenced Adafruits.
Those are fancy drivers.
Yep.
Go look for a simple one.
Go get a simple one. Dirt simple. Anyway, yeah, so there were a couple things there. So yeah, that's probably a good idea. I should probably
Yeah, I've moved away from the Adafruit GFX drivers simply because they're not very efficient and they consume a lot of resources. So I use a different set of drivers when I was running TFTs.
Oh, okay.
You really notice the difference on color TFTs.
Okay.
So what is the higher level software that runs on the cell phone, Ray, and like how do you program it? What?
I was just looking in kind of in the readmes in the GitHub, and there's a section under Android. Let's see if I can get to that. Openbot, GitHub. Bing. Yeah, there's a folder called Android. Okay. And then in the README, yeah, if I can present again.
They have several example apps. You simply download them as applications and execute them.
Right.
At that point, you're into the magic of programming to the Android operating system, which I know nothing about.
Yep, me neither. That's why I wanted to explore this. Anyway, yeah, there's just two barcodes. It looks like one's got I forget what the old controller, not an Xbox.
That's the manual control that uses Bluetooth.
Right. Yeah, and then the other one, it actually shows the robot like with a phone attached to it. So, and they do have a no phone option, so you can do some testing without the phone.
They have one app which is a person following app, so it recognizes people and follows them, and a second app which is used to basically to memorize a route, and once it remembers the route, it will continue to follow the route and avoid obstacles on the route that you can throw in after you told it what the path was. So it has obstacle detection for route following.
Yeah, I was kind of curious if it could be used for 6CAN. I'm not certain if it would actually work for that.
No, you'd probably have to program it, and now you're into trouble. Now you're into a lot more skill set, I think. Although I haven't looked that far into it, so I don't know.
Yeah, I was kind of curious about that, but I don't know. Always been interested in using cell phones to control robots, but
it seems like an enormous technology resource just waiting to be tapped.
Yep. Maybe Kareem could do a special series on that. I don't know. But would you guys like that?
Yeah.
Yeah.
Does Kareem know how to program cell phones?
Oh, he's been using cell phones to control robots for years now.
Yep.
Yeah.
Okay.
But you get deep into the internals of Android, and then in Android there's not much that you're very dependent on sort of the external interface to whatever hardware is doing the actual stuff, motor control stuff, and things like that. So
okay,
it would be interesting to I don't know, some of the controllers that the club has been talking about recently would be interesting targets for that kind of thing. Like the what?
Go ahead.
What did you say, Tom?
Obviously, these guys have programmed an inference engine of some sort. So without knowing any of the details, but if you can determine what environment they were using to do the machine learning, which they then execute on the inference engine they have, it may actually be fairly straightforward to use the platform they use to do the machine learning, get a data model that's compatible with the inference engine that they've already created or already figured out how to install. And then all you have to do is download a new data model and it'll follow something different. So who knows? Might be a simpler problem to solve.
Well, that's interesting, right?
Anyway, so I was kind of curious who else had done anything other than Tom. Have you kind of explored that at all anymore? Or?
After Pat showed me his line following robot last week, I had to get busy on my line following robot.
Pat, you distracted him. Don't do that. Anyway, so I'm gonna actually put one together and see what it can do. And
Oh, cool.
so I've got a couple different platforms that are, in the robot graveyard over there. There's platforms that have been ripped apart and used for other things, and so I've got one with motors with encoders on it, and pretty much nothing else. Oh, the other thing that I wanted to tell Tom about, I think I have, I'm not certain if it's a version 1 camera or version 2 camera, but I had one on a Raspberry Pi, which is compatible with the Seed Studio. I forget what it's called now.
Yeah, the Grove Vision AI version 2.
Right.
I'm using a Raspberry Pi version 1.2 camera, a 5 megapixel camera on mine, and it works just great.
Oh, it does. Okay, yeah, I think
it's a little narrow field of view, but other than that, it works well.
Yeah.
And since I have half a dozen Raspberry Pi cameras, it saved me buying another camera.
Yeah, this one had an integrated filter switch on it, and
oh, that's nice.
So, and I used it a couple times to. I think this one was what I first, did a demonstration for the laser line and determining, distances from, with that, and you could actually switch back and forth, between the two filters, just an IR filter, and then I want to say that was a 780 long pass is I think what it was referred to as. So yeah, I thought that was kind of neat. So it is the same cable and all that.
It's
So
a 12 millimeter standard thread for interchangeable lenses.
yeah, so that's the other thing that I liked about that.
I was looking at whether I should buy one of those fancy cameras so I can get interchangeable devices. All my stuff has fixed camera lenses.
Yep. Yeah, so that's kind of what I've done. I've got like a collection of lenses and you can even buy, a collection that goes from, telephoto to wide angle, and even, ones that either have the IR filter or don't have the IR filter, depending on what you want to do with it. So.
I've collected a box full of old digital cameras, vintage digital cameras, and I keep thinking I must be able to use those somehow, right?
Are any of them CS lens?
They're pocket cameras, so they don't generally have interchangeable lenses, except for my high-end 35 millimeter camera, which is a film camera. I don't know what to do with it.
Oh yeah, I've got one of those, a Nikon.
Yep, me too.
Yep. It's sitting up in this storage location pretty much, and collecting dust. So
yep. Great lenses though.
Yep.
Well, that was really interesting.
Kids will throw all that stuff out when we pass away.
Oh God. I think it'll be like KERA. You can donate your legacy to the robot club. So let who's ever around sort of through all that crap. It's like
maybe I can sell it used and get enough money to buy parts for another robot.
Yep.
Well, thanks,
yeah.
Ray.
For a while there, film cameras were coming around again. It's like ooh, wow, God, these things are unique.
That and LP records. I've got an old transcription turntable sitting here that I can't do anything with because I have no records.
Anyway, that's all I had. I was just kind of
All right.
curious.
Thanks, Ray. Well, that brings us to open mic. So
It's probably like Scott and the the sumo stuff. He's the only one interested in that. I'm the only one interested in this, so
We'll get there.
yep. Anyway, open mic.
open mic. Who found something or knows something interesting?
Well, I mentioned I'm working on my line following robot. It's actually the carcass of something I acquired a couple of many years ago called a chalk tracker. It has I don't know how well you're going to see this if I hold it up. It's hooked up to my scope and a breadboard. You may be able to see the row of holes there with infrared and optical sensors in there.
Yeah.
So you can see that. So there's 8 of them, but there aren't really 8 of them. Once you reverse engineer the circuit, they're paralleled up. So there's 4 of them, and they're symmetrical around the center line. And they go through amplifiers, but first they go through a differentiator, then they get amplified, then they go through a low pass filter. So you can't just set a threshold and read it with a digital input. You have to read them on the fly with analog inputs. So it's going to be an interesting piece of code to get this thing calibrated and working. We'll see how it goes. Somebody probably designed it many years ago. It ran on an 18 mega 328 actually, but it was code protected, so I was never able to figure out what the code was. So somebody must have had a lot of fun working out the algorithm to make these things work out of doors on the typical driveway with the typical stick of sidewalk chalk. They apparently did work, but that must have been a pretty sophisticated piece of processing to do it. I have started to build my test track. There's my test track so far. We'll see how it goes.
Yeah, I don't know if you'd be interested in it. I had code that, well, it actually runs on a OpenMV H7, but I put the resolution down to, I think, either 60 by 80 or 30 by 40, and looked at kind of a U-shaped group of pixels that, in the field of view, and tried to determine what to do by where the line, or they sense the line or the line cross those pixels, in the field of view of the camera. So the kind of the U shape was to catch, something, a line that's squiggled off to the left or the right. You could also look at intersections, because if you have, like an intersection and then you can make a decision, which way to turn. Typically for the challenge course, I think it was always straight. It worked with the shaded areas that were the most difficult to get through, because you're always looking for a fairly large contrast to catch it. The first part of the course, it had, it's like I don't know, I guess it's an acute angle is what it was referred to as. And that was the hardest thing to get through, because it's like you pretty much had to anticipate it, or know, at what time in the course it was going to come, because pretty much the thing was always moving forward. It would never back up. And the acute thing is, okay, the course just kind of comes to a point and disappears beyond that, so it's like the robot would go beyond it, and So that was about, I think, the only thing that would trip it up.
I like to find out what I can about what other people have done to solve these line tracking problems. So I spent some time this morning reading a series of entry-level research papers on how people solve the problem of line following, because it's a very, very common entry-level activity to research how to build these for the automatic guided vehicle field.
Oh, really? Wow.
Big deal, right? And they cover all of these special cases. And what they're attempting to do is to minimize the number of sensors and to strategically locate the sensors in order to cover all of the scenario cases they've come up with for line following. It's very, very interesting to see what they come up with. What I've learned so far is this little line tracker toy I've got really has a bad set of sensor locations.
Oh, yeah.
So I may start over again. We'll see.
Yeah.
One thing that, Tom, that you might be interested in is if you go back and look at the videos on when we were in COVID, and we did the line simulation that Ron Grant had developed, because that gave you complete freedom of sensors. I mean, you could create any sensor array you wanted to, and there were people there were at least 3 who solved the challenge course in simulation. Carl was one of them. Yeah, and I believe that's on video.
Okay,
and,
I will.
And it was us. I believe the software is still out on the software is out in the GitHub somewhere. So I might have to mess around to find it. But that's
I was going to look it up and post a link in here because it's a really nice simulator that he wrote in processing.
Yeah.
Yes.
And then he later went to Java and processing. So you want to make sure you get that version if you can.
Right. So Carl, how many sensors did you have on your robot?
Well, so the way he did it, you could define whatever kind of sensor that you wanted, arbitrary, whether it was physically realizable or not. But one characteristic that applied to all of them was that if you could imagine that you had basically a camera with some arbitrarily big number of XY pixels, you could use the whole or even a single pixel. You could use any combination of pixels in there. So I particularly used, and you can see these depending on how you, I think, I forget exactly how, but the sensor arrays are kind of visible, I think, in the way that he wrote the simulator. But I made in my particular one, so first of all, I modeled, my robot agent was a hover, it was a omni-wheel robot, so it could traverse in any direction. Which has been a thing of mine for a few years. So I imagined that I had a downward-facing camera, and then I only looked at 4 line arrays of pixels. So I had them shaped as like a pound sign or a hash mark. And based on those, it was symmetrical. So it doesn't matter which way I thought of as forward for the robot at any given time, because the sensor was I always had. So I could treat any direction as equal. And with that pattern of sensors, just a line right here, line right here, line right here, a line right here, I didn't have to worry about where in the course this acute angle was.
I can see Pat's paying close attention because I know he's going to use a camera.
Yeah. Well, yeah, a camera is kind of really kind of a cool way to do it.
Yeah.
On mine, I didn't run in the challenge. I ran in the basic and then the advanced. And I did that because I wanted to actually simulate my existing robot to see how close it was. And it was surprising. It also taught me some ways about how to kind of game the course so that I could actually speed up about a second, I think. And and it was, you know, it wasn't, it might not be so obvious. You can place the robot on any place on the course. And so the trick is to place the robot, let me see if I can get this right. It's at either one of the curves right as you're going into it, or right at the beginning of the straight line. I can't remember which one. I'd have to look at the video. But, you know, that placement bought me a second, and I did that from, you know, running the simulation several different ways. And I beat Jesse Brockman by about a half second, I think, because he didn't go through that. I mean, he ran in the advanced too, but he also did, I think that's all he ran, basic. I can't remember. Yeah, he ran basic and advanced, I think, just like I did. But I was really interested in, okay, this is a simulation. How close to real life is it? And it was surprisingly close.
Well, there was one paper who decided he was going to see how much of a solution he could come up with a single sensor. And he actually did very, very well. His analysis is amazing. But most people will pick typically a minimum of 3. Many want more than that. One guy put 64 sensors. It's sort of the sensor equivalent of a camera.
Yeah. Let's see. Who was the gentleman?
I had a question.
Go ahead. Go ahead, Pat.
Before you leave too far, the advanced course you did on for line following. Yeah. Is there a start and a stop point? Because I don't see one on the.
No, you can put wherever you put your robot. That's
advanced.
Okay. Now, you can't put it on the square that has this gap. Okay, you have to. You know, that's kind of a cheat. But I don't think there's a start and stop on that one. I know you can put it in either direction too, because you will find that your robot tends to run, your physical robot will run better in one direction than it does in another, typically. But it's not much, but you know, if you're being competitive, that's the way it is. So,
okay, thank you.
Yeah.
Let you carry on.
But I run, Tom, I took essentially kludged together 2 Polo analog sensors that are, you know, one is they used to sell them in 8. They now have gotten an array that's crazy. But I had an 8 and I added 4 from another one, I believe, or 2 from the other. So I actually was running a extended mine to be 10 sensors, and that worked real well.
Did
I ran 8. I ran 8 a long time, but generally on mine I use 8 sensors, and they go through a comparator, because the line, if you look at how the light is reflected into the sensor at an edge, you will have sort of a sine wave or a very rounded curve, a rounded step. And so you want to sharpen that up so that it pops at the same place all the time. Anyway.
I thought James Leroy was successful at doing, I thought, the challenge course. Didn't he had a robot that swung back and forth, and I've seen some of the Japanese competitors. They're super fast, and I don't think he had that many sensors on his either.
He never did the challenge course. Challenge course challenge course was never, he might have tried it a couple of times, but he never, no. But you saw a lot of, single sensor robots essentially ride the edge, one edge. So as long as you're doing a loop, you have a chance. But it's slow, because when you go around a curve, you have to stay inside. when you have two, you straddle the line. So you're ping-ponging back. And that's the way most Lego robots are done. And if you watch them, they go like bonka, 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 bonka. And they're not very fast either. And then once you get past two, you might as well have 8, 10, whatever. Yeah. But the simulation was cool for Pat. I know he's gone now, but since he could use that to pick his points of interest to simulate any pattern that he would want to. And there are some advantages. Gosh, I wish you might want to look at, I guess, the Robot Builders Night virtual around that competition, because I know people talked about the reasoning behind their different sensor arrays, though I'm sure none of us remember that much.
Yeah, Doug, I just put a link into the chat. So if you search DPRG clips for LFS, you'll find those, hours of those weekly meetings, which included discussions of that. And I know that embedded in there are those ones you mentioned where we talk about our different approaches.
Yeah.
I haven't found the one with the contest yet, though, because that was pretty cool when we actually ran the contest.
Yeah, I sure hope we videoed it.
Oh, we did.
I want to say we did, but yeah, that was a lot of fun. Yeah.
If I remember right, Chris and I each had times of something like 1 or 2 minutes each. For the,
you were like seconds apart though.
Yeah,
you were like really close.
I think he toasted me by just like a
Ray,
second.
and then Ron was he completed it, but he was further away. He came in third.
I don't know if you've ever seen these or not. Okay. Yeah, look at these things. They're just ripping along.
Yeah, so the thing about the challenge course is that it has, this is sort of like the challenge course.
Yeah.
But the challenge course, the problem with we didn't have ramps. But the challenge course doesn't, if you use the same logic all the time, I think it fails. You have to switch up. You have to realize that you're at a location, and instead of, because the classic line, the classic line following algorithm for a 90-degree curve is that you always turn into the side that you saw the line last. Okay, so this is cool. I like this. Where is this from, Ray?
Let's see. High precision line following robot.
Yeah.
They're just a series of videos that, here's one that.
Yeah, that one. They've got every element we have. Except we don't even, they have some that we don't have.
Yep.
Wow.
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 Yeah.
Yep, incredibly fast.
Yeah.
I like the dead end handling. That's pretty good.
You see that the real long, look at how long the robot is, how far away in front of the sensors the sensors are.
Ray, click the full screen button there if you can.
Okay.
That's better.
Oops.
The long length between the sensors and seems to be real common with that type of robot. It's not. Yeah, I'm really. This guy is my brother here. I think he's got. I can see challenge course 2 if you guys beat it. I like it.
Yeah, it's just amazingly fast.
Yeah.
Okay, there's switching black to white, white to black.
Yeah. It's got all, like I say, it's got all our elements.
Yep.
Now, he would have failed because he did not respond to those circles.
Oh, look at him go.
Watch this. There's somewhere up here he just shoots across. Okay, so yeah, on the diamonds he just shot across. So there's some that he technically would have not run the course. That one was okay. It was anyway.
Very fast.
Yeah.
Well, mine will not be that fast.
No.
Anyway, yeah, there's tons of videos of all that stuff.
Yeah.
So.
Wow, that's amazing.
Mm-hmm.
So Ray, just following on from your discussion of Openbot, I was going back through the commit history in several pages in GitHub, and it looks like it's mainly been run by someone called Thias15, who is a German researcher on robotics and machine learning in Munich. And most of the activity in the repo happened before the middle of 2023. And then it kind of went dormant for a while. And then it was a little bit of activity in the middle of 2024. And then a few spotty commits here and there in late 2024. So yeah, what you might do, just a suggestion, is contact that guy through GitHub and ask him if there's any kind of a community or anything going on with that robot anymore.
Yeah. Yep. Yeah, I think them not being available on Amazon, I think sometimes there's kind of a flurry of activity, something new's produced. They even gave you, like I think 3 different options, or maybe even 4 different options on, STL files to 3D print the bodies if you wanted. And I looked at the Ender, I think it's an Ender 3 version 2 or something like that. The print bed is not quite large enough to do the biggest model. I was a little disappointed by that. So I'd have to go down one size to, accommodate my print bed. So, but yeah,
contract it out.
go to the maker space and sit in the 3D print room for a while. So, but anyway, yeah. So I thought it was kind of cool. I was gonna explore it some more, see what can be done with it. So Tom, you were saying you got off on your line following. Are you at all interested in any of that stuff, or was it
in terms of the Openbot?
Yeah.
Yeah,
were you going to?
I am, and it's on my list. And because I have most of the bits and pieces here, it's probably not that far down on the list.
Yeah,
I'm not sure when I'll get to it.
Yeah. Okay.
If I'm going up to Pat's place later this spring, I better have some robots ready to take up there.
Yeah. Yeah. Okay. Well, that's cool.
Well, anyone else got anything? Or are we winding down and approaching time to call it?
Good night.
All right.
It's late.
I think we're 50 people heading out, so.
I'm going to add one more link before you shut down the transcript here. And then,
yeah.
There he goes, a second. It's a pain to get Google to do just the right thing. So just a second. Here we go. Almost. Nope, almost.
Oh, we got it.
Almost. Yeah, I found I found one of them pretty quickly. Who's this? I'm not sure whose this is. It's somebody else's run. Just a second, and I'll find mine in just a moment. Give me a moment, and then just a second here. Is that? I think that's the mine. Just a second, almost there. Oh yeah. Oh yeah. Just a second. There we go. And oh, guys, trying to zoom this in and after a 3-hour recording is such a pain. Almost there. Here we go. Okay, this is it. This is my run. Ta-da. Okay, and then we'll get this in the transcripts. Okay. Okay. 3 challenge course runs, and for those of you looking at the video, if you look closely, I'll just share briefly here. So there's a sample of it of how to interpret this. Present window, this one. So when you look at this, if you see, this is my robot zooming around the course. Here are the 2 arrays that I have. So Tom, if you look closely, you can see that I have I show these white dots when it detects a line, and then the logic that I have uses those white dots with respect to the robot orientation to decide where to go. And it'll be easier to watch in the real time thing.
Maybe click the full screen on the YouTube.
Yeah, I think it's got more to do with streaming ability. Maybe.
Got it.
There you go. But you can see how, I set this, you can set up the sensors in the code to display dots and things in different ways. So I'm showing mine because I know how to interpret it, sort of. You can see that I have different colored dots for representing different logic that the dots imply, how I interpret them. And if you back up to other competitors like, who's this? You can see whoever this is has they have a hemispherical array of elements and ran off the course.
Yeah, that looks like what Ron might have done.
JS maybe, or I think this was Ron's right here.
Oh.
And you can see Ron. Yeah, you're right. Ron RG. He had 1, 2, 3 hemispheres.
Yep.
And he highlighted in red when he saw a line or what he thought was a line. And there you can see his different arrays. So I can see also these square ones going around too, right? So he had a very interesting combination of.
He had every shape covered
that he looked at. Yeah.
In a virtual world, of course, there is no limit on sensors, I guess. Eh?
No, right. Or if you have a camera, right? Because you can decide what pixels you want to look at. And how you want to look at them. So I think all of ours just, we basically just chose some array of pixels and did math on that array of pixels, as opposed to trying to do like, I don't know, transforms of the whole image and pattern recognition and whatnot.
Mm-hmm.
So,
did you find any of the videos of actual your robot running the challenge course?
I didn't look for that. You mean the physical one?
Yeah.
We were doing that? Oh, yeah, no. That's I know where they are.
Yeah.
And it did okay. It was just, for a first time out, you can argue, right? Because that was my first robot. You got to give me a break.
Yep. Oh yeah. It was definitely slow, but it got the job done,
like 1 frame a second or so. but it pretty much did the challenge course in 8 minutes with 2 restarts. But it was that one was distributed. It had a really cheap and incapable physical platform. I mean, no encoders in the wheels, and it had a Pi 0 over Wi-Fi, and then I had a Node.js server on my laptop that was running RoboRealm, which is some other version of OpenCV. So I somehow hacked a Node.js interface to the XML API of RoboRealm. So it was the most convoluted thing in the planet. And then it relied on the 5G Wi-Fi, which was total garbage, or 2G Wi-Fi, whatever it was, at the makerspace. So it was just, it'd be fun to. I really look forward someday to do it again. But doing it with, I really want to do it with a hover sim, with a downward-facing camera. So omni-wheels, downward-facing camera, and a body that looks like a 50s UFO with a tail fin. That's you gotta dream for something, right?
So get a half moon hubcap, maybe? Is that
Oh no, I'll 3D print something, and I have some other little goodies in here too. Let's see, where is it? So I collected this from an automotive lantern battery in my dad's garage, right? So I thought that could be good for just putting on the top, right? You can light it up and you can grab it to pick up your robot, and it has a certain appeal to it, the way it looks.
Maybe have it blink to indicate something. I don't know.
Yeah, you could do a lot with a single red. Yeah. 50s looking thing.
Turn it upside down, it becomes your sensor.
There you go.
You know,
Could be a sensor.